Hello students, good morning everyone. Good morning guys, good morning. Welcome back to the physics session. Today we are going to discuss the numericals based on one-dimensional elastic and inelastic collisions. Based on one-dimensional elastic and inelastic collisions. Very good morning Nana. Sanjay, R.S. Sanjay Krishna, very good morning. Right, let us go ahead now. So first let us see a few questions based on level 2 exercise 2. Based on level 2 exercise 2, then level 2 exercise 1 questions we'll see. The level 1 questions you can try yourself. Level 2 exercise 2. Yes. So first for question number 50, page number 54. Question number 50, page number 54. Let's go through this once, everyone. Let me read the question once. Yes guys, very good morning Mana. Very good morning Tangaprabha, Aisha, Sangamitra, very good morning everyone. Right, so go through this. Inform your friends. Still many of your friends have not joined, and inform them to join fast. Right, yeah. So let us see now. Question number 50. Let us go through this question number 50 now. It is given that a 16-gram mass is moving in positive x direction, plus x direction, positive x direction, at a speed of 30 centimeter per second. While a 4-gram mass is moving in the minus x direction, means negative x direction, at a speed of 50 centimeter per second. They collide head-on and stick together. Their common velocity after impact is. Yes. So what is given here? What you are asking to find? Let us consider this quickly. Let us take the given data. It's given that a 16-gram mass. Let us consider this is our first mass. M1 is equal to 16 gram. 16-gram mass is moving in positive x direction with the velocity of, let us say its initial velocity is u1 is equal to 30 centimeters per second. 30 centimeters per second. And or while a 4-gram mass, let us say it is M2, a 4-gram mass is moving in the negative x direction with a velocity of 50 meters per second. Let us say its initial velocity is 50 meters per second, but it is moving in centimeter per second, not meter per second, centimeter per second, negative x direction. So let us consider this with the negative sign. Negative sign tells about the opposite direction. Okay. Then it is also mentioned that they collide head-on and stick together. That means final velocity of the first one and final velocity of the second one, both are equal to v. So what is this common velocity you are asking to find? And what is this? You are asking to find common velocity. So let us consider before collision, m1 is moving with velocity u1 and m2 is moving with velocity u2. After collision, they are sticking together and moving with a common velocity v. What is this? You are asking to find. Provided they are not moving in the same direction, guys. This is very important. They are not moving in the same direction. So M2 is moving in opposite direction. With velocity U2. So while considering this, we have to take this properly into consideration. So what is given here? From law of conservation of momentum, you can say, from law of conservation of momentum, initial momentum of the system is equal to final momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. V is same, so M1 plus M2 into V. So from this we can say common velocity V is equal to M1, or here you let us write V is equal to M1 U1 plus M2 U2 divided by M1 plus M2 total mass. Here, if you substitute the values, M1 is 60. All here, if you see, all are given in the CJ system only. So try to substitute all in CJ system and try to find the final answer in CJ system. If the final answer is in CJ system, you can keep as it is. Otherwise, at the end, you can convert into SA system if the final answer is in SA system. Okay. So let's go ahead now. M1 U1. M1 is 16. U1 is 30. Right, plus m2 4 u2 is minus 50 because it is moving in opposite direction. Here you have to take its sign guys. Okay, minus 50 into minus 50 divided by total mass 16 plus 4 20 grams. 20 is equal to, what is this, 16 into 3 48. So 480, this is minus 4 5 is 20, so 200 divided by 20. So 480 minus 200 as 280 divided by 20. 0 0 cancel, and what will you get? 14. You get 14. So I have taken all in SCJ units, so this will be in centimeter per second. So the common velocity after collision will be V is equal to 14 centimeter per second. But if you see the options, in centimeter per second only one option is there, that is given as 0.014. So it is not correct. If you want to convert this to SI system, how can you do this? 1 centimeter equal to 10 power minus 2. So you can write it as 14 into 1 centimeter is 10 power minus 2 meter per second. That means 0.14 meter per second also you can find. So that is there in the second option. So second option is the right one. This is how you have to do the conversions also little carefully, guys. So 0.12 meter per second, whereas 14 centimeter per second. Don't confuse. So select the option properly. Next question number 51. Right. Next question number. Next question, guys. Next question. Question number 51. Question number 51. See here. So what is given here? It is given that a bullet of mass 50 grams going at a speed of 200 meter per second strikes a wooden block of mass 950 gram and gets embedded in it. The velocity of the block after impact is. So question number 51, page number 55. So what is given here is there is a small bullet. We can consider this as a small object, M1. Here M1 is given, a bullet of mass 50 gram is moving with a velocity of 200 meter per second. Huge velocity, guys. Keep this in mind. Its initial velocity is U1 is equal to 200 meter per second. So its initial velocity is U1 is equal to 200 meter per second. And it strikes a wooden block of mass 950 grams. So its mass is 50 grams. There is another block mass whose mass is 950 grams. So means comparing with this one is a very heavy one. So it collides with a heavy object, wooden block, which is initially collide with this means there is nothing is mentioned. That means it is initially at rest. So you can say its initial velocity is u is 0. Now after collision, this is stuck with this. So it penetrates into it somewhere here, it stucks. So here this is M1, this is M2. Now both are observed to be moving with a common velocity. This is before collision and this is after collision. After collision both will stuck together and they are moving with common velocity. Now the question is, what is the common velocity? What is the common velocity after collision? Here V1 is equal to V, V2 is also equal to V. Both are moving with the common velocity. What is that? V1 equal to V2 equal to V is equal to what is the question? Again but they are moving in the same direction. Here Okay, so initially the bigger one is at rest, heavier body, and smaller one is moving to the right. So you can take as the sign conventions properly without any confusion. So from law of conservation of momentum, again we can say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here m1 u1 is what is m1? 50 grams. But here what is this? u1 is given in 200 meter per second, guys. Meter per second. So it is given in meter per second. So try to convert this into one system of units by looking into the options. So options are given in SI units or CGS units. By looking into that, accordingly you have to try to convert now or at the end. But all while doing this simplification, all parameters should be in same units of system. Same units, same system of units. So how can you say this? M1 is in CGS system, U1 is in SI system. Convert it into let us say into CGS system. Let us convert here. At the end you can convert it to SI system. So this is equal to U1 can be taken as U1 is equal to 200 meter per second. 1 meter equal to how many centimeters? 100 centimeters. So 2 into 10 to the power 4 centimeter per second. Centimeter per second, because 1 meter equal to 100 centimeters. So 200 can be expressed as 2 into 10 power 2 into 100 means 10 power 2 centimeter per second. 2 into 10 power 4 centimeter per second. So it is this further you can write it as M1 is 50 into 2 into 10 to the power 4 plus M2 U2, as U2 is 0, this term becomes 0, is equal to V1 equal to V2 equal to V. So let us write it as M1 plus M2 into V. This V you want. So here itself you can write this implies V is equal to the left side part is 50 into 2. 50 into 2 is what? Directly write down 100, right? So 100 into 10 to the power 4 divided by total mass. Total mass is how much? 50 plus 950 in CGS units. So how much? 1000. This you can write it as 10 power 3. So can we write this as 10 power 3? So what will you get? Are you taking all in the same units of system? So this we are after simplifying, 3 zeros cancel. Here 3 zeros cancel, 1 zero remains. So 10 power 2 and 10 power 1 is 10 power 3 will get 10 power 3. But all parameters we have taken in CGS system, so this will be centimeters per second. But options now, if you observe options they have given in SI system, so this at this stage you can convert this into the SI systems. So V is equal to 10 power 3 centimeter per second, or if you want to convert the centimeter per second, 1 centimeter equal to how many meters? 10 power minus 2. So 10 power minus 2 10 power minus 10 power plus 3 becomes 10 meter per second. So either way you can write 10 power 3 centimeters per second or 10 meters per second. So which option is right? The second one. That's it. This is how you have to work out. Right. Next. Question number 52. Question number 52. So what is given here? What is given here? Yes. It is given that a block of mass 1 kg, is moving with a speed of 4 meter per second. And it collides with another block of mass 2 kg, which is at rest. If the lighter block comes to rest after collision, then the speed of the heavier body is simple one. So try this yourself before I complete. Try yourself. So what is this? A block of mass 1 kg. Let us consider this as m1. m1 is equal to 1 kg. Moving with the speed of, let us say its initial velocity u1 is equal to 4 meters per second. 4 meters per second. It collides with another block of mass 2 kg. Let us take this as m2 is equal to 2 kg. Another block of mass 2 kg, which is at rest. Its initial velocity u2 is 0. If the lighter block comes to rest after collision, lighter one is this one. This comes to rest after collision means its final velocity v1 can be taken as 0. Then what should be the speed of the heavier body after collision? That is v2 is equal to what is the question? Simple. Again, same by using law of conservation of momentum. You can say from law of conservation of momentum, you can say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So here m1 is 1, u1 is 4 plus m2 is 2, u2 is 0. So this term becomes 0. It is equal to m1 is again 1 and v1 is 0. So this term can be taken as 0 now, plus m2 is 2 into v2. We want to find this now. So on simplifying this, we can write 1 into 4. 4 is equal to 2v2. So 2 times it goes. So the final velocity of the heavier body is 2 meters per second. That's it. I am giving you here step by step, but here while doing in the examination point of view, for saving time, you don't need to do this all these things step by step. Directly you can write just here by looking at this m1 u1. Just you have to you have to imagine all the steps you have to do in your mind, and you have to give the final answer like this. So m1 u1 plus m2 u2. m1 u1 is 4 plus m2 u2 is 0 is equal to m1 v1. v1 is 0, so it is 0 plus m2 v2. m2 v2 you want, so 2 v2. You have to just directly calculate this, and you have to write it as 2 v2 equal to 4. So v2 is equal to 2. Just within 10 seconds you should be able to work out like this way. Okay, so that you can save the time and you can do quickly. Yes, very good, Sanjay. Nice, good, good. So that's also try to respond with your answers, guys. Next, so this is question number 52 in level 2, exercise 2. Now let us do a few questions from level 2, exercise 1. Level 2, exercise 1. From level 2, exercise 1, based on elastic and inelastic collisions. Based on elastic and inelastic collisions. So level 2 and exercise 1. Level 2, exercise 1. Level 2, exercise 1. Question number 40. Page number you can say 47. Page number 47. Yes, let us do here, guys. Yeah, before going through question number 40, I think question number 49 we have not discussed. I have asked you to guys to practice, try this. 50th question we did. Question number 49 we have not. We didn't do 47, 40, 45, 6, 7, 8 we did, and 50th one we did. 49th one. Just I would like to give you this briefly. Then we'll go ahead with question number 40. So before this, just a second, guys. Pointer is not responding. Just a second. Right. See here. First we'll see question number 49, page number 48. So what is given here and what you are asked to find? Let us see. In the two separate collisions, the coefficient of restitution, E1 and E2 are in the ratio 3:1. In the first collision, the relative velocity of approach is twice the relative velocity of separation. Then the ratio between relative velocity of approach and relative velocity of separation in the second collision is. This is also one of the previous year's questions in one of the competitive exams. Okay, so let us note down quickly what is given and what you are asked to find. It is given that in two separate collisions, there are two separate collisions, the coefficients of restitutions are E1 and E2. The ratios is given E1 by E2 is equal to 3 is to 1, means it is nothing but 3 by 1, 3 by 1 or 3 is to 1, right? In the first collision, the relative velocity of approach is, in the first collision, if relative velocity of approach is expressed as u1 minus u2, in the first collision is equal to, the relative velocity of approach is twice the relative velocity of separation, twice the relative velocity of separation, v2 minus v1. Relative velocity of separation is represented as this, the first collision. Then what should be the ratio of relative velocity of approach u1 minus u2 and relative velocity of separation v2 minus v1 in second collision? In second collision is the question. So to find this, let us try to recollect back what is the definition of coefficient of restitution. We know that coefficient of restitution E is equal to relative velocity of separation, relative velocity of separation by relative velocity of approach, relative velocity of approach. So when two bodies of masses m1 and m2 are moving initially with velocities u1 and u2, provided if u1 is greater than u2, then only collision will take place. Then this will approaches this. So before collision, this is the condition, and after collision, the velocities changes to v1 and v2, so that v2 should be greater than v1 here. Okay, so you can say relative before collision, there u1 is approaching this, so you can say relative velocity of approach before collision, relative velocity of approach before collision, relative velocity of separation after collision can be expressed as E is equal to v2 minus v1 by u1 minus u2. So now here you can write, so for first collision u1 is equal to v2 minus v1 by u1 minus u2 for first collision. You can write like this, and for second collision you can be expressed as v2 minus v1 by u1 minus u2 for second collision, just like this. Now the ratio of this is given as 3 is to 1. Now let us take the ratio of these two only according to this. Okay, so this implies E1 by E2 is equal to, E1 is this, V2 minus V1 by U1 minus U2 for first collision, or you can take this as for first collision, for first collision, this of first collision divided by this divided by U2, means you can write it as V2 minus V1 for second collision divided by here in this divided by comes to numerator u1 minus u2 for second collision. Now we are asked to find the ratio between relative velocity of approach to relative velocity of separation second collision. This one you are asked to find. So this for that let us simplify it. E1 by E2 is given as 3 is to 1 or 3 by 1 is equal to, it is mentioned that the given data, it is mentioned that what is this, u1 minus u2 in first collision is equal to 2 times v2 minus u1, or this is 2 times v2 minus v1. If you take it as 2 into that, you can cancel. So here it is v2 minus v1 divided by u1 minus u2 is 2 times v2 minus v1. So E into u1 minus u2 by v2 minus v1 in second collision, for second collision. So this 2 gets cancelled. Now what will you get? It is 1 by 2. Now because this part you are asked to find, you can write now directly. This implies u1 minus u2 divided by v2 minus v1. This is for 2. This is ratio between relative velocity of approach and relative velocity of separation in second collision. It is equal to, if you cross multiply this, it becomes 3 into 2 is 6, or you can also write it as 6 by 1 or 6 is to 1. Either way you can write this one. This will be the answer for your question. So what is that? 6 is to 1. 6 is to 1. That's it. Fourth option is the right one. Note down this. Note down this, guys, quickly. Yes. Again, guys, I am repeating again that whatever we are discussing in these sessions will not be repeated again in the offline class sessions, guys. So try to keep that in mind and attend without fail. Inform to your friends also. Next, so question number, let us see now question number 40. Question number 40, page number 47. Page number 47. So what is given here? What is given here? Let us see. A body of mass 5 kg moving with the speed of 3 meter per second collides head on with a body of mass 3 kg moving in opposite direction. This kind of questions you have to be a little careful. Opposite direction means the sign you have to take like carefully. In opposite direction at a speed of 2 meters per second. The first body stops after the collision, then final velocity of the second body is. So let us consider the data quickly. Try this yourself. A body of mass 5 kg. Let us say this first one, 5 kg, moving with a speed of 3 meters per second. So initial velocity u1 is equal to 3 meters per second, and it collides head on. Means head on means it is one dimensional collision. Okay, head on with a body of mass 3 kg. Let us consider this is second body is equal to 3 kg, which is moving in opposite direction at the speed of 2 meters per second. In opposite direction means we have to take this as u2 is equal to minus 2 meters second, 2 meters per second. Opposite direction means minus. What speed? 2 meters per second. It is again mentioned that the first body stops after the collision. That means final velocity of the first body is v1 is equal to 0. Then the final velocity of the second body is what is v2 is the question. Okay, directly can do it quickly. So I will do for understanding purpose step by step. You can do quickly, guys. Yes, by LCM, by what do you call from law of conservation of momentum, you can say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here m1 u1 is 5 into 3. Directly let us take 15 plus m2 u2. m2 is 3, u2 is minus 2. So you can take it as plus of minus 6 is equal to m1 v1. As v1 is 0, this term becomes 0. m2 v2. v2 you don't know how to find out. So it is 3 plus 3 into v2. So this is 15 plus of minus 6 is 15 minus 6. It is 9. So it is 9 is equal to 3 v2, and hence v2 is equal to 3 meters per second plus 3 with positive sign. That means it will be moving in positive direction. It is plus 3, guys. Plus 3 meters per second. So which option is right? First one. Yes, Sanjay. Very good, Name. Very good. By law of conservation of momentum, we get it is 3 meters per second. Very good. Yes, others finished. Have you finished this? Do it fast. Next, question number 41. Let us do next question number 41. Let's do this fast. Next, go ahead with the next one. If anyone has not completed, you can, of course, you can pause it and you can copy it and you can go ahead even afterwards also. Next one, question number 41. Right. Okay, guys. So, yeah. So, what is given here and what you are asking to find? Yes, Sanjay, what happened now? Sanjay,
Sir, what you are writing we can't see, sir.
you are not able to see.
Yes, sir, what you are writing we can't see.
Means the screen is completely blocked or what?
Sir, no, the screen is visible, sir, but what you are writing we can't see, sir.
What does that mean? Now we are able to see. Now the screen. Now the question number 40 is completed. That is okay. Is it visible?
That is not visible.
Screen is not visible.
Yes, sir.
1 second. Others respond once. Others respond once. Just drop a message in the chat box. Students, drop a message in the chat box. Are you able to see the screen? Are you able to see the screen?
The screen we can see, but what you are writing is not visible, sir.
What does it mean? And the letters are not visible.
Yes, can I reshare, sir?
Okay, yeah, can you send the screenshot once?
Yes, sir, yes, sir.
We can't see. Writing is fast.
Sir, I have sent you a screenshot.
Yeah, let me just check once. Maybe because of the net, your net is loading slowly, or you check. Just try to go back in the streaming. So in the video streaming, it may be. So here, what you are showing here is the question itself. The discussion we have not started. That is what you are showing.
Yes, sir. Like the image is visible, sir. Nothing I have written, sir.
You are getting my voice. Are you getting my voice?
Yes, sir, I am getting your voice.
Oh, okay, okay. But it is just I am checking myself here in the video, but it is showing for me, man. Oh, 1 second, guys. 1 second. No, 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 no. I didn't observe this. I didn't observe this. So I think question number 50 is till question number 50 discussion it was displaying properly, right? 50 was okay.
So level 2 H is only stopped, sir, from question number 40.
Okay, okay, okay. So why the screen? Let me check this. Screen is displaying. Display is okay. I'll stop the session and again start. Just you guys be in line. I mean that live will be continuing. Okay, you can be in the live only. So have you joined?
Sir,
Did you guys join?
so you posted new live, sir,
Not
or
n-
same
not
stream?
not the new live, the same stream only.
Yes, sir, I'm already there, sir.
Okay, okay. Okay, then let me do one thing. Let me just post a new one. Okay. Something is wrong with this one. It is. Yes, other students, try to join the new link. Try to join the new link. I'm trying to post the new one.